Okay, so in this video, I'm going to talk about intervals of convergence for power series. So I'm just going to go through several examples. So the directions here are to find the series radius and the interval of convergence. So I'm going to go through 4 series in this video. So let's just jump right into it. You can pause the video if you want to read them over. Okay, so let's start with A here. So to find intervals of convergence for power series, the nice thing about it is that there's not a lot of creativity involved in how to figure that out. So you're always going to use the same test, so it's the ratio test. So to do that, the first thing that I need to do is I need to take the nth plus 1th term divided by the nth term. And so just to kind of run through the math. Okay, so I'm going to make this first the not efficient version just to make this nice and clear. Okay, so here's the nth plus 1th term. So I literally took all the n's and then changed it to n plus 1. And then I divide that really by the series itself. And so this is not cool to look at. So the thing that I am just going to leverage for all of these examples is that if I have a over b divided by c over d, which is effectively what I have here, that is really a over b divided by c over d. So that is just ab times d over c, right? So I can just go ahead and take the reciprocal of this and multiply it out. So that's what I'm going to do for all of these because this is just taking up too much space. So let me clear some space. And okay, so we'll just multiply by the reciprocal, oops, just the nth term. Okay, so here's everything. And once you get to this point, now it's just algebra. And what else can you do? So in this case, I can cancel out this x to the n, so I can subtract n here. And then I can also cancel out this 5 to the n, so I can subtract 5, or I can subtract n from here. Otherwise, there's not a whole lot I can really do. So what I want to do is I want to write the n's in front and then the x's and the numbers after. So let's just see what I've got. So on top now, I've got n times the square root of n, and then n plus 1 times the square root of n plus 1. And then this is all going to be times x over 5. So this is just how I like to do this. And oops, I forgot all my absolute values. Let's see. Okay. So this is how I like to set all of this up. Now, the thing is that these n's are going to be positive. So I actually don't need an absolute value around this whole thing. I really just need the absolute value around the x's because the x's can be anything. These n's are always going to end up going to something positive, so you can kind of shorthand your notation like this. And technically, I don't even really need absolute value around the 5 because obviously 5 is positive. So if I want to be the absolute most efficient with this, I just really need the absolute value around the x like you see here. Okay, so what else can we do? Well, at this point, I can at least take the n and the square root of n and then the n plus 1 and the square root of n plus 1. I can make this a little nicer to look at. So this is going to be n to the 3/2 over n plus 1 to the 3/2. So this has a exponent of 1. This has an exponent of 1/2. So 1 plus 1/2 is 3/2. So I can rewrite my n's like this. And then I've got the absolute value of x over 5. And then I can shorten this again to be n over n plus 1 to the 3/2. And then the absolute value of x over 5. So I like to try to compress this and put all the n's together as close as or as much as I can because I do have to take the limit of this. And so by doing all of this work, this is going to make taking the limit easier. Okay, so now let's take the limit. So I need some space. So here's everything that we just worked on, but now I've just included the limit as n goes to infinity. So there's a couple ways that you can do this. The way that I like to do this is I just like to divide everything in here by n. So, or you could think of it as multiplying the top and bottom by 1 over n. So then what's that going to give me? So let's see, that's going to give me 1 over 1 plus 1 over n. And then we've still got the absolute value of x over 5. So then that allows me to see that this is going to go to 0. So I'm really just left with 1 times the absolute value of x over 5. So then that's just going to be the absolute value of x over 5. Okay. So now the standard of kind of what you do when you get to this point is we want to figure out like how to treat this part of the power series almost as if it were like a geometric series. So a geometric series converges when this ratio will be less than 1, because that's ultimately so all the n's at the end of the day just go to 1. So this series will converge then if what's left over is less than 1, because then we can treat that like a geometric series. So after you take your limit, you're going to set it up so that it's less than 1 like this. And I have to get x isolated, so I need to multiply 5. And so now this is the radius. So this is the radius. Okay, so we're almost done. So let me clear a little more space. So now you just have to finish solving for the values of x. So this is an absolute value equation, or inequality, sorry. So what I do is I set up the equation like this. And so this is the potential interval of convergence, but we're still not done. So this is always how you just set up solving an absolute value inequality. And then to finish this, now we have to test these two endpoints. So what I like to do is I like to actually plug them in. So let's pretend for a second that I have x equals -5 in this series. So what's that going to look like? This is going to turn into -5 to the n. So I plugged in 5 for x. So I've got the rest of this. Okay, so now I can see that these 5s will cancel out and I'm just left with -1. I'm going to drop the rest of the series notation just for shorthand. So I've got a -1 on top, n square root of n. And n times square root of n, we already talked about this. This is n to the 3/2. So this is written just to look a little bit more confusing. So now I have this, and this converges as a p-series. So this converges absolutely. Okay. So that's the first one. So what that means then is I can add a or equal to here for the -5. And let me erase this and let's do this again for x equals 5. And again, I'll just use the shorthand with the notation. So now I've got 5 to the n over n, 5 to the n, square root of n. And so once again, this actually simplifies. So the 5 to the n's drop out again, and I can just rewrite this as 1 over n to the 3/2. This also converges. So since this converges as a p-series, this 5 here is also included. So this is, maybe I'll just circle it for a second, this is my interval of convergence. And everything converges absolutely. All right. So let's move on to the next one. So it's the exact same set of steps here. So if you're playing along at home here, I strongly recommend that you take a second to try to set this up on your own if you're trying to learn this. That's the best way to really learn math. It's not just watching videos, it's actually doing the math. So I strongly suggest that you start out by doing this test. So just do all the algebra with it and go as far as you can and hit play when you're ready. Okay, so in this case, so I'm going to have x to the n plus 1, natural log n plus 1. So there's the nth plus 1th term, and then here's the nth term. Okay, so let's see. In this case, the x to the n drops out, so I can subtract n here. And I forgot my absolute value again. Okay, So I like to bring all the n terms to the front, and I don't need the absolute value here. And then I'm just left with the absolute value of x. So here's what I need to take the limit of as n goes to infinity. Okay, so let's make some space. So here's what I'm taking the limit of. Now I think sometimes the x can kind of mess with your head. When you're taking this limit, you're really just treating the x like a constant. So, I mean, honestly, if you wanted to, you could bring the x to the front and just completely ignore it for a moment so that you can focus on this limit here. So I'm really just focused on these n's. And now what I notice is that as n goes to infinity, this gives me infinity over infinity, so we can use our old pal L'Hopital's rule. So I take the derivative of the top and the bottom, so I can rewrite this then as n over n plus 1. And then I can either take the derivative again. Let's see, I'll make some space. So you can either, you can take the derivative again since we've got infinity over infinity, or you can divide everything by n, tomato, tomato. So let's see. I'll take the derivative. So if I take the derivative of the top and bottom, now I just get 1 over 1. So my limit here is just going to be the absolute value of x. So once again, now I want to take whatever's left over, and I want this to be less than 1. So in this case, 1 is my radius of convergence. So once you get this absolute value of x isolated, whatever's over here, that's your radius of convergence. Okay, so then how do I set up my interval of convergence? Well, now I set up this inequality, and now I have to test -1 and 1. So if x equals -1, what am I left with? I am left with -1 to the n times the natural log of n. Well, this is definitely going to diverge. So this is just, this is going to be some values that are greater than 1. So this thing is just going to bounce all over. So this is going to diverge. You could also use the nth test for divergence to prove that. So if you take the limit of the n's as n goes to infinity, this whole thing is just going to end up diverging. So that's another way you can prove that. Same thing happens if x equals 1, because then I just get really this series here. This definitely diverges as n goes to infinity. So just this is going to be my interval of convergence. Okay, so let's keep the party going. So once again, I think it would be a really good idea for you to pause the video here and you try to set this whole thing up and then hit play when you're stuck or when you're ready. Okay, so I need to set up the nth plus 1th term, n plus 1, natural log of n plus 1 squared. Okay, and then this times the reciprocal, n times the natural log of n squared, and then x to the n. Okay, so here's all the algebra that I need to sort out. So this x to the n is going to cancel out, and not a whole lot else is going to cancel out in this case. So using that same procedure that I've used before, so I'm going to put all my n's in the front, and I've got the absolute value of x here. Okay, all right, so let's go ahead and take the limit as n goes to infinity, so I'll make some space. Okay, so I've set up my limit, and sorry, I think before I wrote n here as the exponent, it should have been a 2. Okay, so here's my limit. I can ignore the x for now. This part of the limit, we've already played with this, right, in some of the previous limits, so we're pretty confident that this is going to go to 1, so I don't have to worry about this part. So now I have to figure out where does this part of the limit go. Okay, so let's just focus on, so let's see, I'll bring the absolute value of x out, and I'm just going to focus on this part of the limit since, let's see, we'll call this natural log of n over natural log of n plus 1, and all of this is being squared. Okay, so there's a property with limits that says that you like whatever this result is, you can just square that result. So there's a property of limits that says that I can just take the limit of the inside and not really panic too much about this square on the outside. So what I'm saying is I can actually rewrite this if this is kind of throwing me off. So I can rewrite this so that I'm taking this limit and then I'm going to square that result. And this really helps because now I see that this is infinity over infinity, so now we can use L'Hopital's rule. So I've got absolute value of x. Let's see. So I've got 1 over n over 1 over n plus 1, and I'm going to square all of that. And let's see, I'm running out of space here, but I'm going to try to squeeze it in. So this becomes, let's see, the limit as n goes to infinity. Okay, so this will be n plus 1 over n, all of that squared. Okay, so this still gives infinity over infinity. Now I need to make some space. So once again, I can take the derivative of the top and the bottom. So this becomes 1 over 1. So this is just now going to be 1 squared. So ultimately my limit now is just x. So then I need to have this x, it's absolute value of x less than 1. So 1 is my radius, my radius. And so now I need to set up this part. And okay, so let's see, if x equals 1, my series becomes 1 over n times the natural log of n squared. And I can compare this series with 1 over n cubed. So this converges as a piece series, so this whole series converges. So since this series converges, so this converges, so I can include in my interval over here, I'll include the 1. Since this converges, then if I put in -1 to the n, this will converge absolutely. So this one, if I take the absolute value of this, I know since this series converges, then this series converges. So these both converge. And so here is my interval of convergence. Okay, and so for the final one, so this is kind of a wacky looking series, but it's still the same idea. It's almost like a weird factorial. So let's set it up again. Once again, I strongly encourage you to set this up and hit play when you're ready. All right, so if I set this up, so I have 2n, and then, so if you think about what 2n plus 1 is, so because that's what I need to set up, right? This becomes 2n plus 2. So I'm going to also write here 2n plus 2. So there's me plugging in my n plus 1, and then I multiply by the reciprocal. So this now will be 2 times 4 times all the way to 2n over x to the n. So a whole bunch of stuff cancels out now. So in this case, all this 2 to the n stuff cancels out, and then this x to the n cancels out. So what am I left with? I am left with the absolute value of x over 2n plus 2. And so if I take the limit of this, so n goes to infinity, I have the absolute value of x over 2n plus 2. Well, this just goes to 0. So since this goes to 0, what that means is that our series converges for all x. So that's it. Okay, so if that was helpful, please consider hitting the like button or leaving a comment or subscribing to the channel. And I will talk to you guys in another video. Thanks for watching.